Hello learners, welcome to your favorite e-learning platform Pathshala. I'm Savita Chauhan, your mathematics mentor. Let's just start today our new chapter. But before that, let me tell you something that what I did today. Actually, I just went to a fruit shop today and I just bought a variety of fruits. I bought some apples and oranges as you can see in this particular basket. So I bought only two varieties of fruits, that is apples and oranges. So let us suppose if we'll count together that how many number of apples and oranges are there in the bucket. So let us suppose we are counting the number of oranges first. So it is my first orange, the second one, the third one and the fourth one. So there were actually 4 oranges in this bucket. So let us suppose if I'm counting the number of apples. So this is the first one, the second one, third, fourth, fifth and sixth. So the total number of apples in this bucket is actually nothing but 6. So as we can see over here, the number of apples and the number of oranges all together are nothing but 10. So there are 10 fruits all together, or we can say that there were 10 fruits in this particular bucket. So let us suppose if I am creating a kind of a situation over here. Let us suppose if I'm saying the number of apples and the number of oranges all together, they are nothing but is equal to 10. I can say this because we do know that the number of apples were 6, the number of oranges were 4. So 6 plus 4 is nothing but is equal to 10. Furthermore, let us suppose if I'm saying that the number of apples were actually 2 more than the number of oranges, then I can write the situation as the number of apples minus the number of oranges is nothing but is equal to 2, because we do know that the number of apples were 6, the number of oranges were 4, then definitely the apples were 2 more than the oranges. So it means that from the number of apples, from the number of oranges, I can create such kind of a scenario. So let us suppose if I'll convert it into the mathematical terms. Let us suppose I am taking the apples or the number of apples as nothing but x, and I am taking the number of oranges as nothing but is equal to y. So it means that the number of apples plus oranges, that is x plus y is equal to 10 and x minus y is equal to 2, because we have taken the number of apples as x and the number of oranges as y. So from the previous circumstances, we can say that x plus y is equal to 10, and further x minus y is equal to 2, means the number of oranges are 2 less than the number of the apples, or we can say the number of apples are 2 more than the number of oranges. So it means that from the number of apples, from the number of oranges, I can create an equation of such form. So what are these equations, or what do we call these equations? These are actually called as nothing but linear equation in 2 variables. And fortunately, this is our chapter today that we are going to start, that what are linear equation in 2 variables. So as we can see, there are 2 equations over here. X plus y is equal to 10, x minus y is equal to 2. So both of these equations are actually called as the linear equation in 2 variables. So let's just start with our chapter, that what are linear equation in 2 variables. But before that, let us suppose if we are starting with the linear equations. We all are aware about what are linear equations. So let us suppose if I'm talking about the linear equation in 1 variable first. We do know that what is the meaning of a linear equation in 1 variable. There are actually many words in this particular line. First of all, linear equation in 1 variable. So first of all, as we can see over here, it is written that it is 1 variable. It is an equation. Equation means something which do have a left hand side, a right hand side and an equality within. Such a situation or such a type of an expression is actually called as equation, in which we have left hand side, right hand side and equality. So further it says it is linear. What is the meaning of linear? Linear means if the higher highest degree of the polynomial or the highest degree of a variable, we can say, is nothing but 1, then this is called as, or such an expression is called as linear. So let us suppose if I'm talking about x. So x do have a degree as 1 or have a power as 1. So that is why it is called as linear. So always remember, the meaning of linear is in which the power or the degree of the variable or the highest power of the variable is nothing but 1. This is called as a linear expression. So we are talking about the linear equation in one variable. So a linear equation in which there is only one variable, it is called as a linear equation in one variable. So let us suppose if I'm talking about a linear equation in one variable as 2x plus 5 is equal to 0. So obviously it is linear. First of all, as we can see, the degree of the variable is nothing but 1 over here. It is an equation because there is a left hand side, there is a right hand side, there is a sign of equality within, and it is one variable because there is only one variable present. As you can see in this particular equation, 2x plus 5 is equal to 0. First of all, it is linear, it is an equation, and there is only one variable. That is why it is called as linear equation in one variable. And we already are aware about that what are linear equation in one variable. So let us suppose if I'll solve this linear equation in one variable for the value of x, So in order to solve it for the value of x, what can we do? Let us suppose if we'll take plus 5 from this side toward this side. So we are transposing plus 5 from this side to this side, and we are dividing 2 everywhere. So after doing all the steps, we will get the x as nothing but is equal to minus of 5 by 2. This x is equal to minus 5 by 2 is actually called as a solution or a root of this linear equation in one variable. So always remember that whenever we do have a linear equation in one variable, and if we'll find out the value of the variable, for an instance, if we are talking about this particular example and we have taken the value of x as minus 5 by 2, so this value is actually called as a root or a solution of this particular linear equation in one variable. Moreover, we can also represent this particular value x is equal to minus 5 by 2 on the number line as well. So let us suppose if I'm taking the number line over here, so this minus 5 by 2 will actually comes in between minus 2 and minus 3. So this point is actually called as minus 5 by 2, and this is called as a root or a solution. This is called as a root or a solution. So minus of 5 by 2 will be called as a root or a solution. Always remember, solution and root both are one of the same things, and they are called as the root and the solution of this particular linear equation in one variable. It means that a root or a solution can be represented on a number line in such a way. So let us suppose if we'll move forward and we will talk about the situation. We'll talk about the situation or some of the points to remember. Let us suppose if we are talking about some of the points to remember which is related with the linear equation in one variable. So what are those points? It says that a solution of a linear equation is not affected when the solution or the root, or we can say the root of a linear equation is not affected at all when the very first point is the same number is added or subtracted from both sides of the equation. So let us suppose we have an equation as x is equal to 2. If we have x is equal to 2, and if we'll add and subtract any number on both sides, or let us suppose if I am taking x is equal to 2 and I am adding 2 on both the sides, so it will be x plus 2 which is equal to 2 plus 2. So it means that the solution of the linear equation will not be affected at all, because at the end the solution remains x is equal to 2. So always remember, in case of a linear equation, the solution of the linear equation will never get affected when any number or the same number is added or subtracted from both sides of the equation. Furthermore, we have when we will multiply or divide both the sides of the equation by the same non-zero number, again the solution of the linear equation will not be affected at all. So always remember, whenever we are talking about the solution of a linear equation, if we'll add the same number, if we'll add or subtract the same number from both sides of the equation, the solution remain unaffected. Or if we'll multiply or divide both sides of the equation with the same non-zero number, then again the solution of a linear equation will not be affected at all. So these points are really very important in case of a solution of a linear equation. So let's just further talk about the linear equation in two variables, because we are already aware about the linear equation in one variable, but there were some points to remember that were really very important before doing the topic of linear equation in two variables. So let's just talk about linear equation in two variables. So as we can see, we have linear equation in two variables. It means a linear equation should have two variables in it. That's why it is called as a linear equation in two variables. So let us suppose if we are taking the situation again that we have the number of apples as nothing but x, we have the number of the oranges as nothing but y. So we have created the situations as x plus y is equal to 10, and we have created the situation as x minus y is equal to 2. Then they are called as the linear equation in two variables, because there are two variables in this equation as well as in this equation, and both of them are linear because the degree of the variables present over here is nothing but 1. As you can see, x is x raised to the power 1, so its degree is nothing but 1. Again, its degree is also 1. So this is a linear equation in two variables. This is a linear equation in two variables. Moreover, x and y, they are also called as the unknown quantities. They are also called as the unknown quantities. So in the linear equation in two variables, we can also find, or we can also able to find the value of x as well as y. So always remember, in a linear equation in two variables, we also called x, y variables as nothing but unknown quantities. So in this chapter, we will find out these unknown quantities, or we will see that how we can able to find out these unknown quantities. So let's just start with the definition, or with what is called as a linear equation in two variable in mathematical terms. So any equation which is of the form ax plus by plus c is equal to 0, where a, b, c are real numbers and a and b are not both 0, is called as a linear equation in two variables. So always remember, any equation which is of the form ax plus by plus c is equal to 0, where a, b, c are any real numbers over here, condition is a and b both cannot be 0. They are not both 0. It is called as a linear equation in two variables. So let us suppose, if we'll take the example, we have 2x plus 3y plus 4 is equal to 0, x plus y minus 5 is equal to 0. Both of these are nothing but called as the linear equation in two variables, because we can compare this particular equation with the general equation that is given to us. Ax plus by plus c is equal to 0 is called as the linear equation in two variable, and this is also of the form ax plus by plus c is equal to 0. Similarly, it is also of the form ax plus by plus c is equal to 0 form. So that's why it is called as a linear equation in two variables. Furthermore, the previous equations that were x plus y is equal to 10 and x minus y is equal to 2, they are also called as the linear equation in two variables, because we can express them into the formation of ax plus by plus c is equal to 0. So always remember, the general form of the equation, or the general form of the linear equation in two variable is nothing but ax plus by plus c is equal to 0. Always remember, a, b, c are any real numbers and A and B are not both 0. So these are the two really very important conditions, that A, B, C are real numbers and A and B are not both 0. So let us suppose if we are moving on further and talking about the example. So example number 1 is, write each of the following equation in the form of ax plus by plus c is equal to 0 and indicate the values of a, b, c in each case. So let us suppose if we are talking about all these 4 parts, so we have to express them in the formation of ax plus by plus c is equal to 0 and we have to find out the value of a, b and c. So let's just start the solution set of the very first part. Let us suppose if we are starting with the very first part. So the first part is actually 2x plus 3y is equal to 4.37. We have to express this particular situation into the form of ax plus by plus c is equal to 0. So as we know the journal form of the linear equation, let us suppose if I am writing LE, the general form of the linear equation is nothing but ax plus by plus c is equal to 0. So it means that we have to take the constant, that is this particular 4.37 number, towards the other side. So let us suppose in order to express the equation number 1 into the form of equation number 2, we are transposing 4.37 towards the left hand side. So let us suppose we are transposing 4.37 on LHS. So let us suppose if we are transposing 4.37 towards the LHS, so it would be like 2x plus 3y. If it is positive over here, then when it will get transposed from this side toward this side, so it will be negative of 4.37, which is equal to 0. Furthermore, we can write this particular equation as 2x plus 3y plus of minus of 4.37 is equal to 0. We can also express this equation in this form. Why so? Because plus minus is again minus. So this will be minus 4.37. So why I have expressed this particular equation into this form? Because as we can see over here, the general form of the linear equation is of the type ax plus by plus c. So we wanted a sign of positive in between all the terms over here. So that's why I have taken plus over here. So let us suppose if I'm comparing, let's just compare, let us suppose if I'm calling it as 3, let's just compare equation number 2 and 3. So let us suppose if I am comparing the equation number 2 and equation number 3 in order to get the value of a, b and c. So what we can see over here? We have x over here, we have x over here. The constant term with the x is nothing but a, the constant term with the x is nothing but 2. So it means that a is nothing but is equal to 2. Furthermore, we have y over here, we have the coefficient of y as nothing but b, we have the coefficient of y as nothing but 3. So it means that b is nothing but is equal to 3. Now furthermore, we have the constant as c, we have the constant as a minus of 4.37. So it means c is minus 4.37. So at the end, what we have concluded? We have concluded that the value of a is nothing but 2, the value of b is nothing but 3, the value of c is nothing but minus of 4.37. So this is all about writing the equation into the formation of ax plus by plus c is equal to 0 and also finding out the value of a, b and c in such an equation. So I hope all the steps related with this particular part is all clear to you. So now let's just move on further toward the second part. So let us suppose if I'm talking about the second part. So first of all, we can see over here the second part is written as x minus y is equal to root 3y. So this is my second part, x minus y is equal to root 3y. So first of all, we do know that we have to express it into the formation of ax plus by plus c is equal to 0. It means we have to transpose root 3y towards the other side. So let us suppose we are transposing root 3y on LHS. So let us suppose we are transposing root 3y on the LHS, then it would be of the form x minus 4 minus root 3y is equal to 0. So let us suppose if I am rearranging it, let us suppose if I am writing minus root 3y first, so it is x minus root 3y minus of 4 is equal to 0. Again, we do know that the sign in between all the terms should be positive always, so we can write it into the formation of x plus minus root 3y plus minus 4 is equal to 0. We can express it into this particular form because we do know that plus minus is again minus. So it means we can write x minus root 3y minus 4 is equal to 0 as x plus minus root 3y plus minus 4 is equal to 0. Now let's just compare it with this particular journal form ax plus by plus c is equal to 0. So if we'll compare both of these, so first of all we have x, and we do know that if we have x, then the coefficient of x should be 1. So if we'll compare both of these equations, then a is nothing but 1, then a is nothing but 1. As you can see, the coefficient of x over here is a, the coefficient of x over here is 1. So a will be 1. Further move on, we have the coefficient of y as b, we have the coefficient of y as minus root 3. So b is nothing but minus of root 3. Further, we have the constant as c, we have the constant as minus of 4. So c is nothing but minus of 4. So these are the values a, b and c which is related with the part 2. So a, b, c is a is 1, b is minus root 3, c is nothing but minus of 4. So we have expressed this equation into the formation of ax plus by plus c is equal to 0, and we have also indicated the value of a, b and c in this particular part. So let's just move on further towards the third part. So first of all, if we are talking about the third part, it is 4 is equal to 5x minus of 3y. So actually on the LHS we have 4, on the LHS we have 4, and on the RHS we have this particular expression. So it means that if LHS is equal to RHS, we can also express it into the formation of RHS is equal to LHS. We can also express it into the formation of RHS is equal to LHS. So let us suppose if I am writing it into the formation of RHS is equal to LHS, means 5x minus of 3y is equal to 4. We can also express it into this particular form, and again we have to transpose 4 towards the other side. So it will be like 5x minus of 3y minus of 4 is equal to 0. Again, we have to take the positive sign in between. So we are writing it into the formation of this, into the formation of this is equal to 0. So as we can see, we have expressed it already into the formation of ax plus by plus c is equal to 0. Now let's just compare the values of a, b and c over here. So if we are comparing the values of a, b, c over here, so we can see a is nothing but 5, b is nothing but minus of 3, and c is nothing but minus of 4. So this is nothing but the values that are related with this particular form. Now let's just move on further with the very last part, that is the fourth part, which is nothing but 2x is equal to y. So first of all, we have to take y towards the other side. So it would be like 2x minus of y is equal to 0. 2x minus of y is equal to 0. Furthermore, we can write this particular expression into the formation of 2x plus of minus of y is equal to 0. So as we can see over here, if I'll write the general equation ax plus by plus c is equal to 0. So if I'll write the general expression, general equation as ax plus by plus c is equal to 0, we can compare, let us suppose if we are comparing this equation with this, we can see that, or we can note that there is an inavailability of the constant c. As you can see over here, there is no constant. So it means that we can express it into the form of constant as 2x plus minus y plus 0 is equal to 0. Obviously, we can also write this particular equation into this form, because the addition of these terms with the 0 will give these terms again. So addition 0 will not affect the equation at all. So it means that in case if we do not have a constant in any equation of the form ax plus by plus c is equal to 0, so always take c as 0. always take C as 0 if there is an inavailability of the constant in the equation. So if we'll compare both of these equations, then we'll definitely get the answer as A is nothing but 2, B is nothing but minus of 1, because if there is nothing with the y variable, then this will definitely be nothing but 1, because if we have only y, then the coefficient of y will be 1. So it means B is nothing but minus of 1. Further, C is nothing but 0. Further, C is nothing but 0. So A is 2, B is minus 1, and C is nothing but 0. So this is the formation of this particular equation into the general form, that is ax plus by plus c is equal to 0, and this is A, B and C. So this is all about the example number 1, in which we have to express the equations into the formation of ax plus by plus c is equal to 0, and we also have to find out the values of A, B and C. I hope the steps related with all these parts are all clear to you. So let's just move on further.